triangulating all those signals and using a lot of maths, it works out where you are and shows you a little dot on a map. But how do the satellites know where they are? There aren't any landmarks in orbit for them to refer to. If satellites are in a high enough orbit, well away from the atmosphere, at some point, something down here on Earth has to look up in the sky and work out the position precisely. And one of those somethings is hidden away in the countryside of southern England. It looks like a regular observatory, but it's not looking at the stars.
We track man-made satellites in various orbits doing various jobs. They all have to have special reflectors on that enables the light to be returned to us. And so we can measure the time of flight, and from the time of flight derive the distance. You send out a very short pulse of laser light. You do that 1,000 times a second. Each of those shots, because you're using such a tiny short pulse of laser, it's 10 picoseconds long, which is about 3 millimeters. That's the limitation on your precision. So each shot is about 3 to 4 millimeters. Also the temperature and humidity. So we measure those things on site as well. There's probably about 35 active stations scattered around the globe.
Of course, as the light fades, there's one assumption that we've been working on throughout this video, that the Earth, the ground we're standing on, doesn't move. And that's not strictly true.
Anyone, any researcher anywhere can go and grab the international data set, the data from us, from Australia, from North America, from China, from Russia, and can use that data to derive the orbits and do the research they need to do.
Thanks very much to all the team